more clear, you sometimes have a choice. Sometimes a question might say, hey, do this in terms of x or do this in terms of y. But if you don't, then you are going to have a choice. If you're going to do it with respect to x, again, the basic formula is the integral from a to b of the top function minus the bottom function with respect to dx. If you are doing it with respect to dx, then just make sure everything is in terms of dx. So what goes on your integral is going to be x values, and your functions must be in terms of x as well. If you're doing a problem in terms of y, same basic idea, but you're going to think about it as the right function minus the left function, and that would be in terms of dy. But if you're doing it in terms of dy, then the numbers that go in your integral sign would of course be y values, and your function is going to be in terms of y versus in terms of x. One of the biggest mistakes I see is whether you're doing it in terms of x or dy is asking you how many integrals to use. Because sometimes we can set up a problem with just a single integral, like if the top function stays consistently the top and the bottom one stays consistently the bottom, one integral. If they ever like flip places, or maybe you have like three functions, then we know we're going to have to use more than one integral. So that tends to be like the one time I often see mistakes show up. So what I did is I took just 5 graphs, like I took off the equations, and I just want to look at these graphs and kind of decide for ourselves, hey, is this a problem that we would probably want to do with respect to x, or would it be one that we'd rather do in terms of dy, or maybe it doesn't matter because it's equally easy or equally difficult no matter which one we use. So looking at that top row, the first one, if you had to find the region for that shaded region in yellow, which method will be easier, dx or dy? Dx. And again, the easiest way to tell, if I think about dx, I kind of draw lines connecting the top and the bottom. You can kind of see that top function is always the blue one. That bottom function is always the red one. So dx would be the easier one. Why would dy be a little bit harder? Dy is going to be harder because from right to left, it's like the red to the blue, and then it's from like one side of the blue to the other side of the blue. So dy would be much harder to do versus dx. What about that second one? Would you rather do it in terms of dx or rather do it in terms of dy? Dy. Connecting right to left, those functions stay consistent. If you go up and down, the top and the bottom functions are not consistent. So I think definitely dy would be the better choice for that one. What about that third one in the top row, dx or dy? Or does it not matter technically? Technically, it wouldn't matter. So like if you're looking in dx, the top one is always the red one, the bottom one is always the blue one. But you can also see right to left, the right function is always the blue one, the left one is always the red one. So technically, dx or dy are equally easy. If you have to pick, dx is the one that most students are more comfortable with, so I would probably do dx. And honestly, your function would probably already be written in terms of dx, so it would be less work. Looking at that bottom row, those are made up with 3 graphs. That first one in the bottom row, would you rather do it in terms of dx or dy? So if you do it in terms of dx, how many integrals would you have to use? So top to bottom, how many times does it changes places? Just once. So if you're doing it in terms of dx, it would be 2 integrals. Kind of dividing it there. If you're doing it in terms of dy, how many integrals would you have to use? Just 1. Why is it just 1? Right to left. That red one is always the left one, that green one is always the right one. We seem confused in class. I'm going to assume we're also confused in person. I hope we can see why we're using where those 2 integrals are coming from and where like the 1 integral is coming from.
Where's the 2?
The 2 is coming from, to erase some of those lines. Once there it goes. top to bottom, I see a dividing point here. Because on the left side of that line, top to bottom, top minus the bottom would be red minus blue. Top minus bottom would be red minus the green. So we require two integrals if you're doing it in terms of dx. And then that last one, which one would you prefer to do it in, or would it matter?
It wouldn't matter.
It wouldn't matter, they're both gross. Which one would be the better one? Probably dx. You're probably going to be given a problem in terms of dx. Again, if you're doing it in terms of dx, it's still two integrals, top minus bottom and top minus bottom. That bottom function does change. But if you are doing it in terms of dy, right minus left, it also changes with that right function. So either one, dx or dy would work, but for both of them, you would have to use two integrals. Again, is there anything wrong with using two integrals? No, it's going to give you the same answer, but it's just going to be a little bit more work to get to that answer. Now, sometimes it will tell you to set it up with respect to a certain variable, then of course you wouldn't have a choice. You would need to set it up to that variable. So last problem, we're going to do it in two parts, is we're going to look at this one. So I have let R be the region, and close by, we have three graphs here technically. We have y is equal to 3 on the square root of x. I have y is equal to x over 2 plus 4. And then what is the third function? Technically the y-axis. And we want to find the area of that region. It does tell us we need to integrate it with respect to x, so we have to follow those instructions in the setup. And then the instruction that we do like is it says write but do not evaluate the integral, which is a common instruction step in this unit. I use it a lot on the quiz and the test. So just make sure you always read the question because you don't want it to do more work than you need to. We're just going to set the integral and be happy with it. When I'm doing a problem like this, there's definitely some things that kind of show up in my head. I first want to know what the region looks like. I need to know what the top one is, what the bottom one is. I also want to know what it looks like to figure out if I need one integral, two integrals, or hopefully not any more than that, but one or two integrals. And I also want to have a visual just so I can kind of see the starting point and the ending points. This one would be an example of one that we could do without a calculator. So I would expect you to kind of know what these graphs look like without a calculator. If all else fails and you can't remember for the life of you what these graphs look like, just take it back to the 6th grade and just make yourself a good ultimate chart. But hopefully you can draw a sketch. For example, that y equals 3 on the square root of x. We know what the basic square root function looks like, I hope. That 3 function is just stretching it by 3, so I know that function is going to look something like that. Again, I'm not doing a perfect graph. I just need to have some sort of sketch. I know it's going to be starting at the origin. This next function, y equals to x over 2 plus 4, is going to look like what? That's a line. What's the y-intercept of that line? 4. And is it increasing or decreasing? Increasing. Slope is 1/2. Again, notice I'm not doing a perfect graph. There is my straight line. Yes, you can kind of see it's going to intersect again later, but I don't really care about that because what region am I looking at? I'm looking at the region bounded by the square root function, the line, and the y-axis. So that what I have highlighted in yellow is what I'm going to be looking for when I set up my problem. So now before we start labeling anything else, how many integrals am I going to need to use? We're doing this with respect to x. We're thinking about top minus the bottom. For that part shaded in yellow, is the top function always the top function? Yes. Is the bottom function always the bottom function? Yes. So how many integrals do I need to use? Just one. So when I do these problems, I like just kind of setting up just like an empty integral, and that way I kind of fill in everything correctly. Please don't forget the dx at the end, since we do want to say what we are integrating this with respect to. And let's fill in what we know, and then kind of figure out what we still have to find. Well, which one was the top function? The line. So I'm going to go ahead and put that as the top function. X over 2 plus 4. What is the bottom function? That's the one I drew in blue. So that's going to be 3 on the square root of x. Where is this area starting at? 0. And again, that's an x value. It's starting at the x value of 0. Do we know right now where this area is ending at?
No.
No, unfortunately we don't. Because we're looking at it, this area stopping right here, and I don't know what that x value is. So we need to find what that x value is. Well, in math, how are we going to be able to find where that area is ending at? Where they intersect, and how do we find where they intersect? Set them equal to each other. This is often where I often see a mistake as well, mainly from bad algebra skills, not from bad calculus skills. So we're going to go ahead and set them equal to each other. Not the friendliest looking equation to solve. What makes it unfriendly, the square root and the fractions, but we can get rid of those. If I want to get rid of that fraction, what can I multiply both sides by? 2. Again, make sure you multiply both sides by 2. So that's 6 on the square root of x, which is equal to x plus 8. And then what else makes that kind of gross is that square root function. But we know how to get rid of a square root. How do we get rid of a square root? Square both sides. We know how to do that algebraically. 6 on the square root of x is just 36x, which is equal to, please make sure you FOIL that. So I have x squared plus 16x plus 64. And then we just want to solve. Well, I see we have an x term and an x squared term. So what basic algebra skills will we need to use to finish out that problem? Factor. Let's get it equal to 0 and then factor it. Always get it equal to 0 if you're solving by factoring. 16 minus 36 is negative 20. And then we want to factor and solve. Two numbers that would multiply to give you 64, but add to give you negative 20.
Negative something and negative something.
Two negatives.
4,
4 and 16, correct. What does that mean? That does mean that x is equal to 4 and 16. What do we find? These graphs do intersect in two places, the 4 and the 16. Which one am I going to use as like the ending point for that region?
4.
The 4, the smaller one. What is that 16? That's technically where that second intersection point is. But we're not concerned with the area between those graphs. We're concerned about the area between those two graphs and the y-axis. So I'm going to go ahead and put a 16 at the top of my integral. And it tells me to not evaluate it, so that is my answer. How would I grade this? How would the AP exam grade this? You will get 1 point, not 16. I said 4 and then put 16, thanks. So I would lose a point. But how the AP exam would grade this, they're going to grade you for some points for the number that goes on your integral sign with making sure dx is at the end of it. That is part of the formula. And then you're going to get either 1 or 2 points depending on the complexity of the problem for what goes inside that interval. So either a 2-point question or a 3-point question. Question on that setup. How could I change that question? I could say like maybe just like find the area. And if I say find the area, then you would have to set it up and then find the actual interval, which is not difficult. Use the power rule to find the antiderivative and then plug in the top minus the bottom. Evan, you have a question.
So on the AP exam, when we're like trying to like maximize the points, whatever, we just write the integral with, and like if we just have no clue what to do, if we just write the integral with no numbers on the limits and just dx, would we just?
So if you just had an integral with dx, that would be no points.
No points.
Where the points are coming from is you have to have numbers on the integral sign or and something inside that.
They have to be right.
Something has to be.
So wait, so if you don't put any numbers on the integral sign?
So if this was an AP exam, if you just wrote down the integral of x over 2 plus 4 minus 3 squared of x, that would be partial credit. You would earn a point for what's called the integrand, what's inside the integral, but you would lose a point for the numbers on the integral sign. So let's do this question again. This was in terms of dx, which is definitely, to be clear, the easiest way to do this problem. But area is area. You can just kind of look at it from a different angle. And let's do the same problem, but with respect to y. Now let's talk about when we're doing it with respect to y. It's literally the same idea, but instead of top minus the bottom, it's right minus the left. And everything just needs to be in terms of y. So I'm just going to draw the graph again real fast. Actually, I want to sheet and copy it over because technology. So 1 second. And then we'll do this in terms of y. Of course, it's not going to let me.
Nice.
Thanks. I'm a math teacher.
No.
All right. So there's my graph. Same one. We're going to find that same region. But let's talk about it before we even get started. We're doing this within terms of y. When we know we're doing it in terms of y, we're moving from the right to the left of that region. If you're looking at the right minus the left, how many integrals is that region going to use for this problem?
2.
2. And this is where I often see mistakes, is students just go ahead and start using one integral, and that's automatically like you're losing points. Like this requires 2 integrals. Why are we saying it uses 2 functions? So this is always the right function. That is, I think, very clear to most students. But when you think about the left-hand side of it, looking at the region, this lower part, there's the left-hand side, which is basically like the y-axis. But as you move up in that region, the left-hand function is the line. So we do see that we would need to use 2 integrals. We're kind of a dividing point at y is equal to 4. Again, some people like drawing in the vertical lines or horizontal lines to kind of see it. It's like right minus left and right minus left. You can see that you touch 2 different lefts, so we will need to have 2 different integrals. Before I do anything, I like go ahead and just putting down an empty integral, and that way I can just kind of fill in everything I need. We are doing this in terms of dy. I'm going to go ahead and add 2 of them together because it is going to take 2 integrals if we're doing it with respect to dy. Let's fill in the easy part first. I like working from the bottom to the top. Technically, it wouldn't matter which integral comes first. But looking at the bottom to the top, what y value does that area start at? What y value does that area start at? 0. And then what y value is that area ending at for that first region? 4. That would be like that first one stopping here. The second region, well, the first one ended at 4. The second one's going to start at 4. Do we know right now where that second area is going to end at on the y-axis? No, but we do know how to find it pretty easily. If it ended at x equals to 4 in terms of dx, how do you find the y value that goes with a particular x value?
Plug in 4.
Plug in 4. Doesn't matter which equation I use.
No.
No, they're intersecting. You're going to get the same y value. So I'll just use the first one. Y is equal to 3 root 4. 3 times 2 is 6. So I know that the upper limit for that region is y is equal to 6. And now we want to do right minus the left. I don't know why I have a plus in there. Let me fix that. Minus. Right minus the left. But do make sure you plug it in terms of y. So we put a dy there because every single thing has to be a y value. So y numbers, functions in terms of y, everything has to be in terms of y. So for this function, that is y is equal to 3 on the square root of x, how am I going to convert that to be in terms of y? Right now it's in terms of x. Just solve. So we're going to solve for x. Let's divide by 3. And then square both sides. So x is equal to basically y squared over 9. Again, what is that? That is the exact same function. It would have graphed the exact same curve. We're just giving it a different name. Same thing for the line. This is the line in terms of x. Let's give it a new name. Let's put it in terms of y. So I'm going to subtract the 4 and then multiply by 2. So now I have my functions in terms of y. And now I can go ahead and just plug it into the integral, as long as, remember, it's going to be the right function minus the left function. So in this first region, right would be the radical function, but we're not going to use 3 on the square root of x. We're going to use y squared over 9. What's technically the left function for that first lower portion of the region? 0. It's x equals 0. Could you leave off that minus 0? Definitely. I like putting it there just to remind myself like that's where the formula comes from, but you could leave off that minus 0. It's not going to change the problem. Plus this next region. It started at 4, ended at 6. The right function is again that radical function. So that was y squared over 9 minus the left function was that straight line. What was the straight line in terms of y? 2y minus 8. It told us just to set up the problem, so we would leave our answer like that. Clearly, which one would you evaluate? The one in terms of x, because it's one integral and a little bit easier to do. Could you do this one if necessary? Yes, it's just going to be more tedious, so you have 2 integrals to find, 2 antiderivatives, and then plug in the top minus the bottom twice. Questions on finding the area between curves? So that basically area, everything else we do this unit, volumes by cross sections, and then basic volumes of revolution, is built off of this idea of area. So you just remember top minus the bottom and right minus the left, like that's going to be half of all these problems for the entire unit. Biggest mistake I see often is students not being careful when they're looking at these graphs and determining whether it needs 1 integral or 2 integrals. And that tends to be the biggest mistake. So if you kind of remember that, just don't make that mistake, right? Easy enough. So that is where I'm going to go ahead and stop today's notes at. Again, the homework you can go ahead and finish up is homework number 1. Please fill out that form again once you make the decision of when you're taking the AP exam, and definitely reach out to me if you have questions on the homework or that Unit 7 test. Other than that, I will let y'all go ahead and get started. If you're at home, feel free to hang back in the meeting, ask questions if you have them. Try and use this last half hour to kind of knock out as much homework one as you can. Only because the more comfortable you are with area, the easier volume is going to be. Which kind of just makes sense if you're just going up in dimensions. It is going to be very, very closely related. But other than that, if you're at home, I will see you tomorrow. Yes, Samar. This is when you're dividing it in half. Yeah. So you found the overall area, right?
And then, yeah, you just get half.
That's what you're solving for. So just the way I think about it, I kind of like, I'm just gonna draw me a graph. I don't know what it is. But making up a region, so it looks something like this. You know the area of that region, say 4. Well, if we have that area, it would just be 2, right? If I want to figure out the dividing point, then I'll say, hey, well, from 0 to some unknown value of that function, that would need to be equal to 2 instead of 4. So basically, you're going to find the antiderivative, right? And then plug in the top minus the bottom. And the top will be k, and that's basically what we should do. So like we're looking at this one, right? So yeah, this interval. Yeah. Now we choose like, so from -2 to.
Oh, it's pretty. Number 8? I have an 8. That's it. I see. Okay.
So I did it, I just said that. Yeah, so I just didn't finish it,
Yeah.
but I never thought.
You're basically gonna find
Okay.
the speed of
Yeah.
that we're just A is an X value, it's gonna be considered in terms of invalid. Yeah. That's
So we're still going to do
set nothing down like that A value, X value. So it's gonna be considered in terms of X. It tells you
Oh, yeah, it's an eight.
so you have to, you know, vertically like this way instead of that way.
I didn't start
I
this.
think it's like a later.
It's like, I did.
They're both later, so it's like, pictures and like what it's like.
It also said, and it's really cute out there.
So that's the formula, which is negative two.
I like your jeans, by the
You
way.
need to find such prime.
These are like the only things I don't, just gonna say. Ask for like 10 more things.
So like,
What else did you ask? Yes, I did.
Can we add this? Is it like a picture birthday list?
But I did. Oh, but I got these.
find the first.
I got this here. So.
Mm-hmm.
Well, that's what you said, all those here, on our list. I got all those things. I got that. I got those earrings. And I got, these like lilies in there.
Yeah.
I got that.
Oh, like, yeah.
And I got this. And then.
Yep. Mm-hmm.
You don't know what they are.
The blue word.
Yeah, blue. Okay. And then 7 pairs of Air Jordans. Which I'm not getting. They're fucking soda. Oh.
I have a lot of shit to go and go.
And I both of them in the braces. And from the iPad. See, these are options.
This would be my Christmas and birthday list for literally like 3 years. I can never think of anything. to put on there.
I was okay. These pictures were shit. That's the first pair.
I like them a lot.
I'm obsessed with these. If I can find. There's a bunch of
Dying.
and this top.
I just find those one of the best events on it. Just keep not with
I think that would be with the butterfly jeans and the buttons.
something.
With the purse and sunglasses.
Oh,
And then
such a good.
Right. And then I love this one.
That's really cute.
And
My dog's like that.
that's my, that's my bag.
So I do download TikTok and now I
I saw your post, I like it.
Yes. Now, but now like some random creepy. I feel like literally after all of a sudden I get,
I'm sorry.
I accidentally figure out.
I know.
Literally like all of a sudden this person.
You're grown.
Right? I have to do, I have to draft.
You know.
No, I think I do. You're on. It's just, I don't feel they have to.
Oh my god, I think goes.
You can buy yourself some cigarettes.
That's like, really, nobody can even do that.
I can go to
clubs.
Is it cheating? Because it has to be 21 now.
21.
Oh, I forgot.
Also, you can do lottery tickets, that's why
You
you
can
can
buy a lottery ticket.
I'll buy a lottery ticket, and I can also do the bars.
You can go to the casino.
Oh my god.
Casino's 18, right?
Casino's 18, yeah.
Can't rent a car yet, sorry.
That's 25.
That's pretty
Yeah.
old.
It's
Like
like
24.
I think we should be 21 to do that.
They just gotta wait for this men's frontal loser.
True. For girls, it should be 21.
Yes, it should be.
What else should I do? My son should go for me to go buy cigarettes. Just as a power move. And then
Yeah,
throw it
exactly.
Lottery tickets are
Oh my God.
costly ones.
True.
Scratch off.
Yeah, I might do
Look
that.
at this, scratch off and scratch it off and like, oh, we can $2.
Yeah, oh, magic ball, right? Yeah. I have to. Maybe I'll do that tonight.
Let's see if we have it on your birthday.
Yeah. Then I've been kind of obsessed with Allbirds. So we're doing takeout. So my friend said that the secret side Allbirds.
I'm so excited. I can go there and only eat solid red sticks.
Me too.
Alright, for my fire.
Fantastic. I went to Ips the other night. Their red sticks was so good.
I keep meaning to try that.
Oh, Ips is so good. Like the pasta's incredible. I went to now we're at Loyal Tavern, Mr. Brown, so now I have Loyal Tavern.
That's so weird.
It's a sports bar, next in between Salt and 1920. I try to avoid downtown Roswell at all costs, because I don't want to see too much of it.
Well, that's for making me walk.
That's where I saw you twice. I saw you walking once in our tent, like my friend's pets. Yeah, I definitely can see his zest as I watch people
Usually
walk.
at the entrance.
I know, I need a job. Look at the 1920 people smoking cigarettes outside Loyal Tavern, and all of the people look at the Loyal Tavern menu, and then go to 1920.
I just feel like they're all at the same restaurant in that last.
Oh,
But
yeah.
they all just run together in my head.
Weeks or something, a month total.
Like salt, I think it's all just, it's just one restaurant.
Is Ruth still a thing?
Exactly, a month for two.
My brothers were.
But like,
No, that's I went there for Sam's 18th birthday party. I just told my parents, not birthday party, but like a family birthday dinner. I just told my parents, I didn't get my 18th birthday nice.
This is better since last year, I'll set it for new services this year.
oh my gosh, yeah.
Paris? I think we got creamed corn.
Yeah, it's bullshit.
I'm a sucker for corn. It's like I think I got a cream corn size. They were like to share, and I wasn't. I loved it. And it had like a crust, like a.
Oh my god.
No, I want it. Great. I'm gonna be like, for my half birthday, for my children, my half birthday, can we go to Little Alley? You're going to.
It's so good.
It's like coming up.
Oh my god.
May 13th.
Holy cow.
No, my brother got Little Alley's first.
Yeah.
It's also,
Okay. Oh.
it should be in the answer.
Yeah, how did it work? I should probably be working.
I should too.
Yeah, I have no idea on that one.
Which one?
I have to do.
These, I was so confused. I just said, I just said French.
I want to do it, but I don't want to waste
Oh, yeah,
my
yeah, I would do that.
I literally had no idea, there was like 1 minute left, I was like,
My
who cares?
Yeah.
I was like, I don't know. It's making like, use my brain a bit more.
I'll bring you one tomorrow.
Can't eat it.
Mr. Guerrero,
Yeah,
which homeworks do you have to
That sounds
complete?
so good. They're really.
just one and two.
1 and 2, okay.
Like homework 2 that I signed tomorrow, is literally 2 questions, with like I have like, the first one has 2 parts.
Oh my
Second
god.
one has 4 parts, but it's literally like the same formula, just
I'm determined to get
changing the
100.
coefficient or exponent depending on what the cross section
Well, I really want to test, but I do know, in the beginning, I need to get that,
Once we learn it, in like,
Oh.
like 12 minutes max.
Okay, that's
Do I need to solve number 8? No, you don't need to solve number 8. It just wants you to just do the setup.
Yes, it's basically making you move backwards, like looking at the formula, can you figure out what the functions are?
Oh, yeah, that's
They literally the scariest thing I've ever done.
So yeah, it's just working backwards.
Those highways, holy crap.
Did you guys compete against Alfaro yesterday?
I think
See
so.
Molly?
Yeah.
Oh, I love her. I didn't even know she was in high school.
I just said the exact same thing.
I was like, oh, Molly. She's like in 6th grade.
Yeah, she was there.
So sweet. Isha. Was it Isha? Yeah. He always comes.
He almost was Mars, but I don't know.
pattern.
Usually I hiccup once and I say I have hiccups and they don't come back.
Hold your breath.
You just speak them out of existence.
Just hold your breath.
I always thought you
Oh,
had,
wait.
like,
Oh, could you have a
upside down.
straw? Does that actually work? Plug your ears in, plug your nose in the way around and drink.
Oh, I'll do it.
That does help. I did that one time and. Yeah, literally,
Peanut butter?
literally, I'll hiccup once, I say I have hiccups, and that's it. They don't come back.
You're very lucky.
You
are very lucky.
It's so weird.
Sometimes my dog gets hiccups and it's the cutest thing.
Dogs can get hiccups.
I
Yeah.
have
Because your
diaphragms.
diaphragm's spazzing.
And he'll like look around like
Like you did
he
it.
like doesn't know like why it's happening to him.
You see, I don't have any pets, which is really
Or he'll think that
sad.
someone's like touching him or something and he's just like, he'll go, and he'll be he's just like, what is happening to my body?
That's so sweet. You're just curious.
Mr. Brown,
Yes.
hi.
You feeling
So-
better?
Yeah, I told you like last week I need to make it my test this week 'cause I'm sick. And I'm pretty sure it's not COVID. I think it's just bronchitis.
Mm-hmm.
Still, it's still been kind of rough.
Yeah, you sound a little rough.
Yeah, I sound terrible. But so I know we have a quiz on Friday.